Hello everyone, welcome to my YouTube channel. My name is Ernie. In this video, we will explore how satellite and remote sensing technology help us detect oil spill from the space. Let's dive in. But first, I will explain about the oil spill and how to detect it from the space. So, have you ever seen an oil spill in the ocean and wondered how we detect it from the space? There is two types of sensor used in oil spill detection. One is the passive sensor and the second is active sensors. Passive sensor rely on sunlight while active sensor emit their own signal and detect the reflections and allowing them to operate day and night and through cloud and fog. And for passive sensor, including the visible cameras, infrared sensor, and NIR used in hyperspectral sensors like Aviris, Modis, Meris, and there is we can use the ultraviolet sensor or the passive microwave. And for the active sensors, most notably radar systems such as the SAR or SLAR and a polarimetrics radar and laser fluoro sensors. And radar, especially a synthetic apparatus radar or SAR, applies with rules. So the radar system send the microwave signals toward the sea, toward to the sea surface, and tiny ripples called capillary waves reflect this signal backs. So in the sea without the uh, and create without the oil, it's looking bright patterns, and this is known as a sea clutters. And when the oil presence here on the surface of the sea, it suppresses these capillary waves. As a result, the radar shows darkness areas where the oil is located. Because of this contrast, help us to identify the oil spill and uh, the area without the oil spills. This is the radar bands for the oil spill detections. We can use X bands, C bands, or L band, but the most effective for detecting oil spill is you can use X bands, but open source data it's not available, so we can use the C bands like Sentinel. It's open source, so you it's public, so you can use this data set. So today I will show you how to use from the cbands or Sentinel-1 data sets. And there is different polarization we can use, VVVH, HH, or SV, but true VV is the most common for the operational devices due to having the highest returns powers. So we can see here there is differentiate between when we use the X bands or C bands or sorry, S band and L bands. So L bands it's the lowest contrast. X band is the highest contrast. But the problem there is no data. Open source data is very and this is the limitation if we use the SAR data. There's noise, but we can manage with the filterings, speckle filterings, and there is issue about the incident angles, spatial coverage, resolution, and the temporal coverage. And there is a limitation of the SAR oil spill detection. Its name look alike. Uh, so oil spills from the SAR, it's a look like the newly formed sea ice and the alga blooms. If we see from this image, we can see that the alga bloom is showing dark areas, dark images, and similar like the oil spill here or the alga blooms. So because of this, there is limitations of this data set. Even yeah, there is advantage like we can use this data set night and day, and for it can through the cloud or fog, something like that. Okay, let's jump to the codings. So we will go to the Google or engines, but first you should sign in this platform. After you sign in, you can go to the code editor. In code editor, you can write your code there, and okay, need a little bit times. Okay, first we should define your ROI. Today I will use ROI from my country, Indonesia, Balikpapan Bay here, because in 2018 there is a oil spill in that area. So here, let's draw our ROI. Okay, today I will show you how to draw ROI using these tools. Just draw something like this. You can write or draw your ROI based on your study area using these tools. Okay. And then as I mentioned before, we will use data from Sentinel-1 data SAR data set. Here, if you want to know about the data set, you can read in the description menu here, and about the bands. There is four bands you can use here. Just import it to the window. So I have already write the code here. For Sentinel-1, we will use the data Sentinel-1. This is the polarization we use. As I mentioned before, we will use VV polarizations for filter dates. From the information that I have in this area in 2018, there is oil spill. This is the map from the Lapan have already mapping in this area in 2018. So the oil spill happens, it's around March and April. So in our code we will use this date. We'll use that the date is April, and the day is 1 until 5 fifth. And transmitter receiver polarization, I use VV polarization, and for the instrument mode I will IW. And if you want to know how many data set that you have in this time, you can write print here. Sorry, print, and then run it, and you will get the in the console you will get how many data set that you have. And here I have already make add to the layer of the Sentinel-1 data. We will compare, and this one is for the The speckle filtering I have already used, or I have already processed it, and we will compare it without and with the speckle filterings. And this charts, histogram charts, is I use for find the threshold in my area, because I should differentiate between the water and the oil spill. And my area is minus 25. Maybe in your area it's different. You can find, just change this value as your area, which value for the threshold. And after that, this is for the masking, and this is for the area, how many kilometers or how many hectares. Here is how many kilometers, that's oil spill area in this place. Okay, this one is for the export or to the G drives. This is the format file is SAP. Okay, that's about the code. And let's compare without the, okay, this is for the Sentinel-1 data. You can see this is without the speckle this is without the speckle filtering. You can see the dark area is the oil spill, and after the speckle filtering, so there is so many noise, it's removed here. And this is after the masking, so we get the area of the oils spill. So if you want to only the masking, only the mask, or only the area, this is, and this is for the HZP of the save file of the area. So if you compare, you can see it here from the Lapans, and this one from Google Earth engines that we have already processing. Okay, that's from my side. I hope you can learn something from this tutorial. And if you need code, you can write in the comment. And if you need another things, you can write in the comments. And see you in the next video. Bye bye.